Okay, basically orbital is a part of shell. Orbital is a part of shell. Shell is a circular path on which electron revolves around the nucleus of an atom. Basically, we are quite interested to find out the address of an electron, so that to find the exact address of an electron, we need to know some you can say data, like related to the number of shells, related to the number of orbitals, and also the subshells. So basically, orbital is the area the area in which the probability of finding an electron is maximum. That particular area is called orbital. Basically. Let's suppose this is your home, and these are different rooms. And this is you can say these room 1, room 2, room 3, and room 4. And in room 2 you are sitting. In room 2, let's suppose in room 2 you are sitting, and I want to locate you. I want to find out the address of, let's suppose, anyone else, let's suppose. So I need some information. Number 1, country name, city name, street number, then house number. Let's suppose I have reached to the gate of this house, that is, the house number is 238, let's suppose. Now I'm going towards electron. As I'm going towards electron, so basically the probability of finding an electron is going to increase. After reaching to your home, now I need to know in which room you are standing. The whole area is just like an atom. This is an atom, but the probability of finding an electron is not maximum. I know that electron is within this particular area, but I don't know the specific area. So basically, when I get to know the room number in which you are standing right now, then it's mean that the probability of finding electron is going to increase. That particular area is called orbital. So we have different orbitals, just like a shell. So number 1, we have s orbital, then we have p orbital, then we have d orbital, then we have f orbital, basically. Now I want to know the shapes of different orbitals. So remember, the shape of s orbital is spherical.
Okay.
It's dumbbell shape. It's double dumbbell. And this is complex. I cannot draw on the notebook. Spherical means just like that. Dumbbell means just like that. Double dumbbell means just like that. And this is complex.
Mm.
So, as you remember, when you used to write down the configuration of calcium as I have asked, then you told me that 2, 8, 8, 2. It means that this is the first shell, this is the first shell, this is the second shell, this is the third shell, this is the fourth shell. Now you
Mm.
can see the radius, the diameter. As you are going further away from the nucleus, as you are going from further away from the nucleus, so the size of the shell is going to increase. This is the largest, this is large, this is small, this is smallest. The point is that when you are going further away, when you are going further away from the nucleus, number one, the first point, energy of shell, energy of the shell. Can you tell me it increases or decreases? Yes,
Decreases.
it increases. Why?
Oh.
Because this is a nucleus. In the first shell, I have two electrons. So, opposite charges attract each other. Opposite
Mm.
charges want to attract each other. So when we have two electrons in the first shell, so they would be having a greater attraction towards the nucleus. So it's mean that when there is attraction between the oppositely charged particles, so I can say that the shell is stable, it's having a lower energy, it's having a lower energy. And those shells in which, let's suppose I have 8 electrons in the last shell, just like that, obviously electrons are negatively charged particle, they have attraction towards the nucleus, but as they are further away from the nucleus, as they are far away from the nucleus, so it has a lower attraction, the weaker attraction. So it's mean that they have higher energy. So it's having a highest energy. This is the reason. This is the reason
Mm.
when it's going to react with someone else, so it's going to lose its outer electron. Why they are going to lose their outer electrons? Because the outer shell is having the higher energy. When something is having a higher energy, so they want to gain their stability after losing or gaining electron. This is the reason they never lose their electron from the first shell. It's stable. Why they are going to lose their electron? Just like a noble gas. Noble gases don't react with anything else because their shell is complete, they are more stable, they are inert. Why they are going to react with each other? So this is the reason. As we go further away from the nucleus, so the first thing is that energy of the shell increases. Number two, the size of the shell increases.
Okay.
Then if we discuss s orbital, so remember s orbital is, you can say that it's directionless. It's directionless. I mean to say that, let me draw the s orbital just like that. This is, yes, x, y, and z.
Mm.
This is spherical shape. This orbital is lying on all the axes at a time. It's lying on x-axis as well, it's lying on y-axis as well, it's lying on z-axis as well. So it has no direction, it's just like a soccer ball. When you are going to have a soccer ball, and if I ask what's the direction of this ball, you can't say anything. You can't say anything
mm,
because this is lying on all the axes at a time. So this is, this is a directionless orbital. And then let's suppose, as we have different shells having the different sizes, having the different energies, same goes with the orbitals. Let's suppose when we have 1s orbital, so obviously it's having a smaller size, it's having a smaller size and more stable, and more stable means the lower energy. The lower energy, as I can say that the first shell is having a lower energy, as this is more stable because this is near to the nucleus. And if I'm going to give you the 2s, so the 2s is having the larger size. It's mean
mm.
that when, let me draw the 2s orbital just like that. This is your 1s and this is your 2s. What I'm supposed to do, just I would be drawing in this manner. It's very simple.
Okay.
It's very simple. As you can see, the size of a sphere is going to increase. So obviously this is 2s, large size, less stable. Less stable means more energy. Less stable means more energy. More energy, I'm supposed to write more energy. Same goes with the p orbital. Same goes with the p orbital. If you draw this p orbital just like that, this is x. This is px. Because I have drawn this orbital on x-axis. I can also draw this
Okay.
orbital on y-axis. This is py. Then this is pz. Okay, this is pz, right? Okay, this is pz. So we can draw p orbital on different axes as it has a particular direction. If you are going to make this orbital on x-axis, that would be called px, then would be called py, then they would be called pz. What does it mean? It means that you are going to discuss the, you can say, the different paths of rotation of electron. Electron can rotate on px, x-axis. Electron can rotate on y-axis. Electron can rotate on z-axis. In international books, now if you can see your also A-level book, Roger Norris, you will see
Mm.
that they have used the word electronic cloud. They have used the word electronic cloud. What do you think if I'm going to mix them together just like that? Just like that. If I'm going to mix them together just like that, this is the
Mm.
whole and soul p orbital. Oh man, when the electron would be revolving just like that, just you will see. Let's suppose I'm standing over here. Let's suppose I'm standing over here and I'm just looking. So I will see electronic cloud. I will see electronic cloud. So same thing is that we are going to discuss separately how the electrons move in different orbitals, in different shells, in different subshells. So basically we have three important things in AS: shell,
Mm.
orbital, subshell. We need to know these three things. to find out the
Okay.
exact location of an electron. Right now we are discussing orbitals basically. So this is px, this is py, and this is pz. I cannot say regarding s that this is sx, sy, sz, because it has no direction. That's why. Okay, so these are the
Okay.
spins px and py and pz. Then we have d orbital. Then we have d orbital. The shape is not
Mm.
the part of syllabus. The shape is not a part of syllabus, but you must know that d orbital further has 5 subshells: dxy, dyz, dzx, dx square y square, dz square. No need to memorize this. I'm just telling you that if someone asks how many subshells d orbital has, so you will say 5. Just like if I ask how many subshells are there in p orbital, you will say 3. How many subshells are there in s orbital, you will say only 1. That is itself. That is itself. So in short, I can say that s orbital, then p orbital, then d orbital. Then we don't discuss f orbital because they are having complex shape. But remember, f orbital is having total 7 subshells. Total 7 subshells basically. Okay.
Mm.
Uh, then just like a shell, how, like, what is the maximum capacity? Just like a shell, I want to know the maximum capacity of different orbitals. So s orbital can have maximum 2 electrons.
Okay.
P orbitals can have maximum 6 electrons. Ten electrons, and F can have 14 electrons, and F can have 14 electrons. These are the maximum capacities, as you know, regarding the shells 2, 8, 8, 8, 8, and so on. Same goes with the orbitals. Same goes with the orbitals. Okay. Okay. Afterwards, afterwards, we have to do electronic configuration. Okay, on the basis of orbitals. But the thing is that the problem is that the problem is that, like, let's suppose you told me that this is the calcium 2, then 8, then 8, then 2 configuration of calcium.
Mm.
Why I have put 2 electrons in the first shell? Why I'm not going to start just like that? Why? What's the reason?
Because its capacity is 2 electrons.
Oh, the thing is that you are supposed to fill that shell which is having a lower energy. Let's suppose I have a meal and you are hungry since 7 days and I'm hungry since 30 days. Let's suppose, just imagine. Obviously, I'm having the lowest energy.
Mm.
I need to, like you can say that I need meal first. So if we have different electrons and I have different orbitals in front of me, and I have to fill these orbitals, then I need to decide to which orbital I'm supposed to give electrons. So remember, we are supposed to give electrons to those orbitals, to those shells which are having the lower energy. This is the scientific answer basically. That's why we are supposed to start electronic configuration from the first shell, because the first shell is having the lower energy, because this is closest to the nucleus. Are you getting my point?
Yes.
Exactly. But the thing is, it's quite confusing. How can I decide which orbital is having a lower energy and which orbital is having a higher energy? How can I decide? So there is a principle that is called Aufbau principle. That is called Aufbau principle. Okay,
Hmm.
that is called Aufbau principle. It's not a name of scientist. It's a Latin word which means that building up. Building up. See this. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, then 4, 5, 6, 7. S S P P P P P P P D D D D D F F F F F. This is the first arrow. That's enough. Okay, the first arrow is on 1s. Am I right?
Yes.
And दूसरा arrow,
2s,
then third,
2p,
then
3s,
hmm,
3p,
hmm,
4s,
hmm,
3d,
hmm,
4p,
hmm.
5s,
That's it.
4d. Okay.
Okay, so you can memorize this. You can memorize this. School, school, public school, Daud public school. Basically ये यहाँ से ही आया है, मैंने टेबल जो बनाया है. And
Hmm.
also it's mean that s orbital is having the lowest energy, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, then 4p, then 5s. And if I'm going from left to right, energy increases. तो मुझे इलेक्ट्रॉन पहले किसको देना चाहिए? टू दोज ऑर्बिटल which are having the lowest energy. That's why I would be starting from 1s, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, then 4p, then 5s. That's enough. That's so enough. Like you will not see more than 30 electrons. Okay. I told you the maximum capacities. This is 2, this is 2, this is 6, this is 2, this is 6, this is 2, this is 10, this is 6, this is 2. Am I right? Am I
Hmm.
right?
Yes.
Good. Chlorine is 17. What's the electronic configuration? You will say 1s2, 2s2, 2p6, 3s2. How many electrons are remaining? Mm-hmm.
7.
Exam. No, 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 no. आप वही सोच रही हो 2,8,7. It's not just like that.
Hmm.
Basically, it's orbital 2 plus 2, 4.
Hello?
Yes, yes, yes. I don't know. The signals are dropped. So yes, I was asking how many electrons are remaining for chlorine. I told you that 5 electrons are remaining. Am I right?
Yes.
What's the advantage of this configuration? Basically, this number is going to tell you the period. This number is going to tell you the group number. This is going to tell you the block. So magnesium is in S block, it's in group 2, it's in third period. So this is the configuration that would be telling you the address of an element. Are you getting my point?
Yes.
Yes. So we would be doing electronic configuration from hydrogen to zinc. Hydrogen to zinc, like proton number 1 to 30. Proton number 1 to 30 basically. Okay. Mhm. Can you
Yes.
tell me scandium? Can you tell me scandium? Proton number is 21. Mm-hmm.
It 2s2, no 1s2, then
Mm-hmm.
2s2, then 2p6,
Mm-hmm.
and then can you like show me the diagram? Oh, 3s2,
Mm-hmm.
and then 3p6,
Mm-hmm.
and
कितने हो गए?
then
2 plus 2
when
4 plus 6 10 plus 2 12 plus 6 18.
yeah, and then 4s3, no
4s.
4s2, and then 3d1.
Exactly. Good. Good हो गया जी, good हो गया, good हो गया. Chromium 24. This would remain the same. Argon. This is argon.
Hmm.
This is argon. This is 18. So that would be 4s2 and 3d4. Am I right?
Yeah.
Okay. So we would be inshallah discussing all the things related to this.